All right, in this video, we're going to look at a one-way ANOVA. A one-way ANOVA is where you have kind of like a independent samples t-test, but with more than two levels. So you've got an independent variable with three or more categorical groups, and then you've got a dependent variable of interval or ratio data that you can average. Okay, so let's look at what this would look like. Our research question is going to be are scores on introduction to psychology exams, are they different between the schools in the UT network, Knoxville, Chattanooga, and Martin? So what we've got here is we've got a school variable and a grade variable. And let's look at on the backside what it looks like. Where we've got school, and we've got our value labels here, Knoxville, Martin, and Chattanooga. And I did 1 for Knoxville, 2 for Martin, 3 for Chattanooga. And then our grade variable, which is just a numerical variable. And we've set up the levels of measurement here where nominal for school and scale for grades. Okay, and remember, you can set them up however you want, but your dependent variable needs to be a scale variable, and your independent variable is going to be a nominal variable. Okay, and again, we can turn the labels off. We can see our numbers behind school if we need, but we're going to leave them that way so we can see. We've got 30 measures for each one, and you can do it with whatever you need, but 30 measures on this data set. We got 30 for each one that you see there. Now, the way we run our one-way ANOVAs, we go to Analyze, Compare Means, and One-Way ANOVA. Now, to run your one-way ANOVA, you've got your dependent and factor variables, but dependent and independent variables. Now, remember we said our independent variables are group, so we put that in our factor. So schools are independent, and that goes into factor. Now, the interesting thing with an ANOVA that's different than an independent samples t-test is that it does every level that you have. So if you have 15 levels, it will compare all 15 levels to each other. So since we've got 3, it's going to compare all 3. Your dependent variable goes in your dependent list. Now, a couple different things when you run this test than other tests is that first you have to go into options and ask for descriptive statistics. It won't automatically give you things like mean and standard deviation, but we're going to turn that on and say, give us descriptive statistics. And the other thing is your post hoc test. Now, as a rule, you may only want to run a post hoc test if you have a significant result, but in this case I know this is going to be a significant result, so we're going to go ahead and turn on our post hoc test, and we tend to stick with a more conservative one, which is going to be your Scheffé post hoc test. Now there's a lot of different options here, but just go ahead and pick out Scheffé here and hit continue. Alright, once you've done that, you can run it. All right, so what we're going to see here is we're going to see descriptive statistics on top, means, standard deviations, and a lot of other information, but instead, let's just go ahead and say, all right, let's stick with our mean standard deviations. Knoxville is going to have a mean of 82.93 and a standard deviation of 9.47. You see Martin's 85.2, standard deviation of 3.26, and Chattanooga 80.00 with a standard deviation of 7.04, okay? Then what you have below that is your actual test. Now remember, in an ANOVA, we run an F test instead of a T test. You have your F statistic over here, and you have your significance right here. What we see is that that is a significant p-value. It's less than 0.05, so it is significant. Now we also have our degrees of freedom. Remember, you have your 2 parts of degrees of freedom here now. You have 2 and 87. Are your degrees of freedom that you report. Okay. In doing all of this, we also have our post hoc test. Now, we would only read the post hoc test if it's significant, and since it is, we do read it. And we look for, remember, we look for stars. We look for little stars in here, and we see a star comparing Martin and Chattanooga. And we have Chattanooga and Martin here as well. But what that tells you is that the difference between Martin and Chattanooga is significant. It's a difference of 5.20, right? So 85.2 versus 80.0. The difference between Martin and Knoxville, or Knoxville and Martin, even though there is a difference, it's not significant. And what you see here is the significance reported 0.021. That's less than 0.05. Okay? Same thing, Knoxville and Chattanooga, that's not significant either. So the only difference we have is between Martin and Chattanooga, where Martin has significantly higher scores than Chattanooga. So let's look at how to report all this. We don't need this one here, so I'm just going to go ahead and delete that so we can have a little bit of room to work. Okay, so down here, we'll just insert a text box. That way we can start typing. Okay, so what we have to do with a one-way ANOVA is a little bit more involved than a t-test. So you have to say what you ran. A one-way ANOVA showed a significant effect of what? Of school, and that's our overall variable category. All right, so that's our kind of like, you can say, your variable name. So an effect of school on what you measured on introductory psychology grades. Okay, and then report your test statistics. So report your F values and everything here. So F, capital italicized F of 2, space 87. Oh, comma, not period, comma, space 87. Okay, those are our 2 degrees of freedom, are between and within degrees of freedom. 2, 87, space equals space, and then our F statistic, 4.08, right here, 4.08, comma, and then our p-value, italicized lowercase p, and our p-value is 0.02, so equals 0.02, period. All right, so what you say in the first part is that there is a significant effect. Now the assumption then is that, okay, there's significant. What's significant about it? So you have to run a post hoc test. So in the second sentence, you describe the post hoc analysis. You do so by saying post hoc analyses. And what criteria did you use? Using the Chaffee post hoc criterion indicated that the average score on introductory psychology tests was significantly higher. Now, we have to report the ones that are significant, and you don't report the ones that aren't significant yet. So the only one that's significant is Martin and Chattanooga. So it's significantly higher for Martin than Chattanooga, so we report that. So they were significantly higher at UT Martin, and report the mean and standard deviation. So the mean for Martin is M, capital italicized M, of 85.20. Standard deviation equals 3.26. The test was significantly higher at UT Martin than at UT Chattanooga. And then mean and standard deviation there. 80.00, SD equals 7.04. Period. Okay, that's your significant tests. Now, you've reported Martin and Chattanooga, and there's one more category you haven't reported. Now, you don't have to report non-significant tests, but you do need to report all of your means. You have to get all your means in there, essentially. And if it helps you to report non-significant tests, that's fine. But in this instance, since we've said Martin and Chattanooga were the only significant ones, the assumption is that there was no significant tests involving the UT Knoxville campus. So you can just say that. So you can say, and then what you're trying to do though is get in the mean and standard deviation somehow. So there were no significant differences involving UT Knoxville mean oh, that's what's going on, is our box is not large enough. Mean equals 82.93. SD equals 9.48. And that's it. So that's your reportage. If there's any other little tricky parts to it, then you can kind of get a little bit creative, and we'll go over a few of those in class. But overall, this is a simple way to report a one-way ANOVA.